Alright, lecture 4 here. We're still in chapter 1 and we are wrapping up all of chapter 1 now. We're going to be in section 4. We're going to go over reciprocal identities again. We've already did that in the last lecture a little bit. And we want to talk about the signs and the ranges of the function values. Alright, we have the Pythagorean identities that we're going to go over, and we're going to start learning those. And also the quotient identities. So, we went over this in the last lecture. Alright, we talked about for all angles of theta and the relationship between sine and cosecant, cosine and secant, and tangent and cotangent. Now, last lecture we did it with the ratios, right? So if sine was y over r, that meant cosecant was, the other way around, r over y. This shows that relationship. Okay, this is important for us in solving them later on because we can rewrite sine as 1 over cosecant. We can rewrite cosine as 1 over secant, tangent as 1 over cotangent, and then vice versa. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. However, just remember, the relationship is always sine with cosecant, cosine with secant, tangent with cotangent. Some people want to put the cos together. They are not. Just know that they don't go together. If you can remember that. Don't get confused with those. Alright, so now we're going to start using some trig identities, alright, to actually find some values. So this kind of ties into what we did as last lecture as well, but we're still going to use how these two are related. So we want to find what cosine of theta is given that secant of theta is 5/3. You should already be thinking in your head, well, can I flip these? Or is cosine related to secant directly? Absolutely. Alright, so this should be an easy one in your head. We're going to rewrite that and replace, we're going to write cosine in terms of secant. When we do that, cosine of theta is 1 over secant. Alright, so that's going to be 1 over 5/3. And remember, when we, rules of fractions, you guys hate fractions probably still because your teacher gave you a calculator instead of taught them to you. But when we divide fractions, we end up multiplying by the reciprocal. Alright, so in this scenario, we're going to get, we multiply the numerator and the denominator by 5/3. So you end up with 3/5. Now in your head, you're like, hey, they're inverses. I could have looked at the problem and said, alright, 5/3 has to become 3/5, and then it's in terms of cosine. Okay, just want to be able to review the math piece here. So we started with secant of theta equals 5/3. I want to make sure that we're able to get where that 5/3 turns into 3/2 when we do it the other way. So remember, we took cosine of theta, right, and we said it was equal to 1 divided by secant of theta, okay? And then we substituted in, so we said that cosine of theta, I'm going to fix that there, that's kind of different, alright? So we're going to have cosine theta, that's still really ugly, but we'll deal with it, is 1 divided by 5/3, okay? So remember, rules of fractions, okay? Rules of fractions for us is when we divide fractions, we multiply by the reciprocal. So remember, the reciprocal of this is not a squiggly, but a 3. Get this down for you here. So this is a 3 over 5, but we have to multiply it in terms of 1. So what we do to the numerator, we have to do to the denominator, okay? So when this works out, we have to multiply by the reciprocal of this 5/3 right here. The reciprocal of 5/3 is 3/5. We multiply the numerator, so 1 times 3/5 in the denominator. Well, these essentially cancel and go to 1. So that's why we end up getting 3/5, maybe. Somehow my connection's not going well here on this guy. Alright, so we should end up equaling 3/5 if we do this. Alright, so I just wanted you to see where, when we divide fractions, what happens when we do that. So just so we can review and do another one here. Alright, so just so we can review, alright, if we divide fractions. So when we do that, alright, if you have something like 2/4 divided by something like 1/3, okay, so when we do that, we multiply by the reciprocal. So I'll change colors here for you. Alright, so now when I come over here, I'm going to multiply the numerator and the denominator by 3/1. 3/1. Alright, color didn't change well for you there, but alright, these cancel and end up being 1, right? 3/3 goes to 1, and then we end up multiplying here. 2 times 3 is 6 divided by 4, and we know that that reduces down to 3/2. Okay, so I want to make sure that you guys got that down when we start doing more of these problems, that when we divide fractions, we multiply by the reciprocal. Another thing I wanted to review real quick from last lecture I didn't get to on this in time. I'll do it on this one. So on this one, alright, I wanted to talk about getting rid of a radical in the denominator. So last lecture we had something like 1 over the square root of like 5. Alright, and what we wanted to do was anytime that we had a radical in the denominator, we need to get rid of that. Okay, so that's where we had to rationalize the denominator. So we had to multiply by the square root of 5 over the square root of 5. And it left out a step in my last slide, so that's kind of what I wanted to fill in. Alright, so when we do that, we come over here. Alright, so 1 times the square root of 5 is the square root of 5 on top. Alright, on the bottom, square root of 5 times square root of 5. When they're both under the radical symbol, we can multiply them together. So you get over the square root of 25. Really don't like my tablet pen here. Alright, so when we do this, alright, we're moving on, and we get the square root of 5 divided by 5. Alright, because the square root of 25 is 5. So there's where we had to do that. Anytime we have the radical in the denominator, you're going to do that as well. Okay? So hopefully that helps kind of fill in some of the missing math steps that we have going on there. Alright, let's work through this one now. We want to find sine of theta, and we're given cosecant of theta equals negative square root of 12/2. Well, we should know that sine and cosecant are related to one another, right? So I can literally just flip this one, but then we have to rationalize that denominator. So this becomes negative 2 over radical 12, and then we have to, what? Rationalize the denominator like we did in the last example, okay? So in this case, sine of theta is 1 over cosecant of theta, so you can write it this way as well. Then it becomes 1 divided by a negative square root of 12/2, and we have to multiply the numerator and the denominator, okay, by the reciprocal. So we're going to multiply the numerator and the denominator by negative or square root of 12/2, okay, and negative square root of 12/2. Alright, so let's fill in some of the steps here just in case. Alright, so we have sine of theta equals 1 over cosecant of theta, and we substitute in this for cosecant of theta, negative square root of 12/2. So we have 1 divided by negative square root of 12/2. Okay, so when we did that, we have to multiply by the reciprocal when we're doing it in this case. Alright, so remember we're going to multiply the numerator and the denominator by negative 2 divided by the square root of 12. When we do this, let's see if I can get this to right here. Alright, negative 2 divided by the square root of 12. Okay, so what happens is these cancel and become a 1, right? So that's when we multiply by the reciprocal, because we're dividing fractions out. So this ends up being negative 2 divided by the square root of 12, right? Sorry, it's a little tough on my drawing pad here. Negative 2 divided by the square root of 12. Got a special little house looking thing here we'll clean up a little bit. That's one big radical sign. Alright, so now we have to rationalize that denominator. Okay, so if we remember how to do that, because we can't leave it in this form, we're going to have to multiply the numerator and the denominator, alright, by the square root of 12. So when we do this, alright, we're going to get negative 2 times the square root of 12. Sorry, this is not fun. That dot is insignificant. Alright, this becomes the square root of 144. Alright, so I'm going to come over here and rewrite it where I got a little bit of space over here. This is very choppy and not a good connection somehow. Alright, so when we do this, alright, that simplifies down to negative 2 So, sorry, I had to take a break there and rewrite this. So we have negative 2 square root of 12 divided by 12. So this simplifies down into negative square root of 12 divided by 2 goes into 12 what? 6 times. So it ends up being negative square root of 12 over 6. This can also reduce down. This becomes negative, alright, square root of 4 times the square root of 3 divided by 6. Now why did I do that? Why did I pick 4 and 3? Well, 4 is a perfect square. So the square root of 4 is 2. Alright, so when we do this, it ends up being negative 2 times the square root of 3. Alright, all over 6. We're not done. We can reduce this fraction, right? 2 6 becomes 1/3. So this becomes negative 1/3. I can write on this little tablet thing here. Negative 1/3 times the square root of 3, which ends up just being, alright, negative square root of 3. Give me a second. This ends up being negative square root of 3 divided by 3. It's going to be a lot more little difficult for me to do all this with this little tablet here, but we'll make the best of it this semester. Alright, moving on to the next problem. Alright, so once we rationalize the denominator, I worked through all this on the little writing piece, but we might stick to just doing the PowerPoint animations instead. You guys waiting for me to use the little pen, but we'll see as it goes here, okay? Alright, so we ended up, I showed you how to do that. We got negative square root of 3 over 3 as we move on. So, signs of function values. So, what's important about this is knowing when all of the trig values are positive. Alright, this is something that's important that you're going to need to remember. Alright, sign is always positive in the first quadrant and the second quadrant. Well, let's break down the quadrants first of all. Okay, so in quadrant 1, all of them are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, alright, tangent and cotangent are positive. And in quadrant 4, cosine and secant are positive. Alright, so what am I talking about in quadrants, and what is a quadrant? The quadrants can look like this, okay? If we look and we see the x-axis and the y-axis, okay, you see the Roman numerals, the blue ones, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Alright, so quadrant 1, all functions are positive. In quadrant 2, sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive, and in quadrant 4, cosine and secant are positive. A best way to remember this, and notice the quadrants go counterclockwise. So quadrant 1 is in the upper right hand corner, quadrant 2 is in the upper left hand corner, quadrant 3 is in the lower left hand corner, and quadrant 4 is in the lower right hand corner. The best way I ever remembered this was all students take calculus. All students take calculus. Write that down. All students take calculus. All applies to the first quadrant where all the trig functions are positive. The second one is students. Students goes with sign. Okay, so students goes with sign, so sign is positive. Okay, then the next one is take. So all students take. Take goes with the third quadrant, and take starts with a T, just like tangent starts with a T. So tangent and cotangent are positive there. And then calculus starts with a C, so does cosine, and that's the fourth quadrant. So if you can remember all students take calculus as you go around this, that'll help you remember, hopefully, which quadrant, which function is positive. Alright, so let's take a look here. We want to determine the signs of the trig function. Alright, so when we say signs, is it going to be positive or negative? Missing that. So if we look at angle A, or example A here, 87 degrees. Okay, which trig function is going to be positive in 87 degrees? Well, what quadrant does 87 degrees lie in? 87 degrees lies in the first quadrant, right? If we step back and look here, alright, and take a look at the quadrants, this is where the quadrantals come in, and we need to make sure that we understand that. 87 degrees is in the first quadrant. So let's draw the quadrants here real quick. So let's review what's what. Okay, in quadrant 1 goes from 0 degrees to 90 degrees. Quadrant 2 goes from 90 degrees to 180 degrees. Quadrant 3 spans from 180 degrees to 270 degrees. Quadrant 4 expands from 270 to 360. Okay, so that's just review. I also wrote in there all students take calculus, so we know in the first quadrant all trig functions are positive. In the second quadrant, sine is positive. Okay, third quadrant, tangent's positive, and fourth quadrant, cosine's positive. Alright, so just another quick review. Just wanted to make sure we recall what angles go in what quadrants, just so we can get through this and understand exactly what's going on here. So I wrote in our problem here. So 87 degrees lies in the first quadrant, so all the trig functions will be positive. And then 300 degrees lies in the fourth quadrant, so the only thing that's going to be positive there are what? Cosine and secant. Cosine and secant will be positive in the fourth quadrant. Everybody else will be negative. So here's why. Any value or any point in quadrant 1, x is going to be positive, okay, and y is going to be positive over here as well. So all x's and all y's are going to be positive in the first quadrant, right? X is positive in this direction, x is positive in this direction. Over here in quadrant 2, we're going to have what? Negative x's and positive y values. Alright, because anything going up is positive, anything going to the left of 0, 0 here is a negative x value. So that's why sine is positive, because sine is associated with the y values. Alright, it's a vertical piece, not a horizontal piece. If we look in the third quadrant now, what do we have going on? We have a negative x and we have negative y's in here as well. Okay? So we have negative x's and negative y's. Well, if x is negative, that means sine's negative. If x is negative, that means cosine is negative. If y is negative, that means sine is negative. Okay? But remember that tangent is the ratio of y over x, So negative over negative is a positive, so that's why tangents are positive. Alright, and then if we look in the fourth quadrant, we have positive x's, and we have all the y's are negative here. So what's positive? The horizontal components, or the cosines. What's negative? The y's, or the sine values. So that's where all of that comes from, is what's positive in what quadrant and what's negative in what quadrant. So just remember, all students take calculus, and that will really help you out there. So we walked through this now, and we know that 87 degrees is the first quadrant angle, and it's positive for all the trig functions. And we know that 300 degrees is in the fourth quadrant. It's only positive for cosine and secant, all right, and it is negative for all the other trig functions. All right, how about negative 200? Let's think about what quadrant that's in. So negative 200, remember, we're starting at the x-axis and we're going clockwise. So negative 200 puts us in what quadrant? Well, if we go negative halfway around, that's negative 180. So this is in the second quadrant. Negative 200 is in the second quadrant. So for us, what's positive in the second quadrant? Sine and cosecant. Everybody else is negative. So it's making sure that we understand how those angles get into those quadrants. Okay? So let's identify a quadrant, if possible, that we can do that satisfies these conditions. Sine of theta is greater than 0, and tangent of theta is less than 0. What does that mean? That's asking, we want to find the quadrant where sine is positive, right, greater than 0, and where tangent is less than 0, and tangent is negative. So what quadrants, okay, does that narrow things down to? Well, sine is positive in what quadrants? Sine is positive in the first quadrant, and sine is positive in the second quadrant. So those are our only two choices when sine is positive. Which one of those two quadrants, quadrant 1 or quadrant 2, is tangent negative in? Well, everybody's positive in the first quadrant, so it's not the first quadrant. It can only be the second quadrant. So that angle theta has to be in the second quadrant, because sine's positive there and tangent's negative there. Alright, so let's look at B. Why don't you pause the video for a second, see if you can make sure that you get B correct, and then unpause it and follow along. So we want to look here where cosine of theta is less than 0, so where cosine is negative. That happens in quadrants 2 and quadrants 3. And we want to know where secant is negative. Secant goes with what? Cosine. So cosine is negative in quadrants 2 and quadrants 3. So there's two solutions for this one. So it could either be in quadrant 2 or quadrant 3. So we want to talk about a range of sine and cosine and what they fall into. If you remember talking about domain and range and that sort of thing, so we're looking at all the possible y values of sine and cosine. So the interval or the range that sine and cosine oscillate in between is negative 1 and 1. And we did that when we were looking at the quadrantals and going around. Alright, that's sine and cosine always have to stay between negative 1 and 1. And that'll make more sense when we start talking about the graphs of sine and the graphs of cosine. Alright, we can change the amplitudes, but the general basis is sine and cosine stay between negative 1 and 1. And we're talking the range, so we're talking the y values. Okay? Tangent, the range for tangent goes from negative infinity to positive infinity. The range for secant and cosecant, okay, that looks kind of funny. It's the set, or it's a union. So when we look, I'm looking on the interval notation on the far right. We can go from negative infinity all the way up to negative 1 and include -1, and we can go from 1 to infinity. Now, what's the difference between brackets and parentheses? Okay, brackets mean we include the value, so it can equal that value. Parentheses mean we get really close to that value, but it can never be that value. So that's how we denote if we need to use parentheses or if we have to use brackets. And that makes a big difference if we have an inequality that has a line under it or doesn't have a line under it. So if you look in the set builder notation, right, I'm talking about the inequality symbol there, the little alligator type symbol that you learned it probably has. Alright, if there's a line under it, it equals a bracket. If there is no line under it, it equals a parentheses. So kind of in more simplistic type terms here, okay, if we take a look at this, alright, and we have a symbol that looks more like this, okay, or we have this one, right, and the lines included, that means we're going to use brackets in our notation. Okay, so those imply we're including the value. If we just have the inequalities that looked like this, alright, your less than or greater than type sign, those equate to parentheses. Okay, so if I said that something like this and I had like -5 is less than or equal to x, which is less than 8. Alright, if I wrote that in interval notation, I don't like that 8, sorry. If I write that in interval notation, it's going to look like this. I'm going to include the -5, alright, and then I'm going to do what? Not include the 8. So there's how we use brackets and parentheses when we define these. So that's why, you know, when we look at the interval notation, we can include those values. And we're going to go over the graphs of those later on in the semester, so it'll make a little bit more sense. So let's take a look and decide whether the statement is possible or impossible. So what you should do is, in your notes, have this table. And we're going to reference this table and see if it works. Let's take a look at that first one. Is sine of theta equaling 2.5 possible? It's not, right? Sine has to be a number between -1 and 1. 2.5 is not a number between -1 and 1. So it's not possible there. Let's look at tangent. Can tangent of theta be equal to 110.47? Tangent of theta can be anything between what? -infinity and infinity. So yes, tangent of theta can be equal to 110.47. Let's look at secant of theta. Secant of theta, can it equal 0.6? We go back over here and I'm looking at interval notation where secant is. Can it equal 0.6? No. It has to be between -infinity and -1 or 1 and infinity. Alright? Since 0.6 is less than 1, it fits between -1 and 1, so nope, secant of theta cannot be 0.6 for a solution. It just won't be possible. Alright, so I'll set there so you can pause this and write that stuff down. Alright, and we'll move forward to the next example. We have an example here. It says, suppose that angle theta is in quadrant 2. And sine of theta is 2/3. Find the function values of the other 5 trig functions. So when we do this, the first thing I recommend to you is draw this out. Draw it. It'll make it so much easier for you. The 2 represents what? The vertical component of the triangle. What's the 3 represent? The magnitude or the hypotenuse of the triangle. And then we're going to have a -x value that we got to calculate. Alright, so The 2 is with the y, the 3 is with the r. Then we have to calculate, all right, the missing piece. So when you have to find the missing piece or the leg, all right, we use the Pythagorean still, but now it's x squared, x is what we're looking for, plus 2 squared, so that's like x squared plus y squared equals r squared, right? We substitute in the values of y and r and solve for x. So x is the square root of 5 when we solve that. It's plus or minus, and in this scenario we have to choose correctly, okay? It's the negative one, because the x value has to be negative because cosine is negative in the second quadrant. Okay, so we have to choose the correct x value there. X's are negative in the second quadrant. Alright, if we were to draw this angle, so this is drawing it. Alright, if we do this, okay, if we do this, we get this piece right here. Alright, this is not, yes, no, this is correct. X is negative square root of 5, the y is 2, and the magnitude is 3. So now we can write all the trig functions. You can drop a perpendicular and get your triangles. Now we know what cosine is because we know what x, y, and r are. We don't even need the picture now. We just know that cosine is x over r. Secant is that flipped, right? So secant is negative 3 over radical 5, and we have to rationalize the denominator when we do that. Okay, so I left the steps up there for you to follow. And then tangent is what? The opposite over adjacent, or the vertical over the horizontal, which is negative 2 over the square root of 5, right? But that square root of 5 has to be rationalized because we can't have a radical in the denominator. Alright? So now that we know cosine, secant, tangent, we can do cotangent by flipping tangent. We don't have to rationalize anything here because it's the what? The horizontal over the vertical. So negative square root of 5 over 2. Cosecant is the magnitude divided by the vertical, or the what? The hypotenuse over the opposite. So 3 over square root of 2. Alright, write all of these down. These are going to be very, very important. They will be fundamental. You need to memorize them, and we will be using them in calculus as well. These are the Pythagorean identities for trig functions. Okay, so we're going to use these all the time this semester and next semester. An important one is sine squared theta plus cosine squared theta equals 1. This kind of sounds like what? A squared plus b squared equals c squared? Absolutely. Alright, the next one is tangent squared theta plus 1 equals secant squared theta. And the other one is 1 plus cotangent squared equals cosecant squared theta. Alright, so sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. Okay? Let me know if you have questions about any of those in class. We don't have to prove them, but we are going to apply them. Okay? These are called the quotient identities. What's quotient really mean? Remember, quotient means division. So we're dividing. So in this case, it's a simpler way to rewrite tangent of theta. Tangent of theta is sine over cosine. Because why? Remember, tangent was opposite over adjacent? Well, what always dealt with the opposite side of your triangle? The sine did. What always dealt with the adjacent side? The cosine did. Alright, so tangent is opposite over adjacent, or sine over cosine, or y over x, as we've done before. And then cotangent is just the opposite of that. It's cosine of theta divided by sine of theta. Okay? So those are the quotient identities. We're going to use these to solve trig functions here. So we want to find sine of theta and tangent of theta, given that cosine of theta is negative square root of 3 over 4, and the fact that sine has to be greater than 0. That's important because that tells us what quadrant we're going to be in. Okay, if the cosine has to be negative because it's defined as negative square root of 3 over 4, and sine has to be positive. Where's the only place that happens when cosine is negative and sine is positive? The second quadrant. That's important because it lets you know how to draw things out here. And for you, decide, looking at cosine is what? X over R. Alright, so you have an X, you have an R, you can now find Y. Once you know Y, you know sine of theta. But we can do it a little bit differently, and here's where we apply the Pythagorean identities. Alright, you can do it the other way and draw a triangle and find all the missing parts. If you remember how to do that from a couple lectures ago, alright, use that and solve, that's fine. But we can use the Pythagorean identity to find sine squared, and then use square root to get sine. But if we use sine squared plus cosine squared equals 1, we know what cosine squared is, or what cosine is. We can substitute what cosine is in for cosine and then square it. Okay, so negative square root of 3 over 4 replaces the cosine of theta. Okay, so we're substituting it in, and we have to square negative square root of 3 over 4. Please remember, when you square root a negative number, it's positive. Okay, so when we square this, we get square root of 3 squared is 3 over 4 squared is 16. So we have to, since it's negative, right, or we're going to subtract it from the other side. So we end up with 3/16. So we're going to have sine squared theta plus 3/16 equals 1. We need to rewrite 1 in terms of 16. So you should be able to do 1 minus 3/16 and get 13/16. So now that we know that sine squared theta equals 13/16, alright, in order to find out what sine is, we have to square root both sides. So we're undoing a square. When we square root both sides, and this is one thing you need to remember, when we actually take the square root as we're solving for a problem, the solution is always going to have two, a plus or a positive solution and a negative solution. We have to know which solution to choose based on the condition that sine has to be greater than 0. So in this scenario, sine has to be greater than 0, so we choose the positive square root of 13 over 4. For our final answer. Alright, we have to choose the positive root here because the question defines sine of theta has to be greater than 0, which means it has to be positive. Alright, let's find tangent of theta using the quotient identity. We're still, I know that it looks like we moved on, we're still using this knowledge right here of what sine and cosine are. Okay, so we're going to use square root of 13 over 4 for sine of theta, and we're going to use negative square root of 3 over 4 for cosine theta. So we're going to this is just kind of continuing on with the example here. We're going to use the quotient identity. So tangent of theta equals sine of theta over cosine of theta. And we're going to substitute in the values that we already found. We found that sine of theta had to be square root of 13 over 4, and we were given that cosine of theta was negative square root of 3 over 4. This is where we have to, what? We have division of fractions, right? So we have to multiply the numerator and the denominator by negative 4 over the square root of 3. Alright, because that's what the denominator is. So if you don't remember that, go back to earlier in the lecture where I showed how to multiply by the reciprocal to the numerator and the denominator. That gets us negative square root of 13 over 3. Is that an acceptable answer? You should say no. And you should tell me because the radical's in the denominator, so we have to rationalize the denominator, so we're going to multiply the square root of 13 over 3, the negative square root of 13 over 3, by square root of 3 over square root of 3. So when we rationalize that denominator, alright, we get negative square root of 39 divided by 3. Can you break up 39 nicely? No. We can get 13 times 3, but neither one of those are a perfect square, so they're not really relevant to helping us. Once again, just emphasizing making sure that we're choosing the correct sign when we take the square root. Knowing that when sign was positive there, we have to keep the negative value here as well for tangent. Alright, so we're going to use trig identities to find function values now. So we want to find sine of theta and cosine of theta, given that tangent of theta is 4/3 and theta is in quadrant 3. So what's in quadrant 3? A negative x and a negative y. So we got to be careful there, okay? So just because tangent of theta is given as 4/3, okay, that's because the negative over the negative became a positive. So we have to know that since we're in quadrant 3, when we do our sine and cosine ratios, that has to be negative. Okay, so when we choose those, they're going to be negative. So how do we know? Well, remember, tangent of theta is sine of theta over cosine of theta. So we know that sine of theta has to equal 4, and we know that cosine of theta has to equal 3. But once again, we're in the third quadrant. Cosine and sine are both negative in the third quadrant. Alright, so we have to know that sine of theta is negative 4 and cosine of theta is negative 3. Let's use the other Pythagorean identity. We have tangent squared of theta plus 1 equaling secant squared theta, and we're going to use that to find secant, and then using that to find cosine of theta. Alright, so just remember we're using the tangent value from the previous part of the example right here. So I'm not pulling 4/3 out of the air. This is the first part of the example here where tangent of theta is 4/3. So we're going to move on that to find secant of theta here. So we're going to plug in the tangent value that was in the first part of this problem, that's 4/3. So we're going to square 4/3 and get 16/9. Add 1 to that. Okay, that's going to give us what secant squared is, and then to get secant, we got to take the square root. Alright, so you're going to have 16/9 plus 1, which is 1 is in the form of 9/9. So you're going to have 16/9 plus 9/9, so you're going to get 25/9 equals secant squared theta. How do we undo a square? We have to square root to both sides. So when we square root both sides, we're going to get the square root of 25 over the square root of 9, which is 5/3. Alright, but we have to remember, are we going to choose the negative one or the positive one? Well, since we are in a specified quadrant of quadrant 3, the only thing that's positive in quadrant 3 is tangent and cotangent. So we have to choose the negative value here for secant of theta. So secant of theta is negative 5/3. If we know what secant of theta is, we should obviously know what cosine of theta is now by taking the reciprocal. Alright, remember the reciprocal is just flipping it. You're taking 1 over itself, but it's really flipping it around. So it ends up being negative 3/5 for the cosine function. Then, okay, if we know what cosine is, right, we just found cosine here is negative 3/5. We can use cosine to find sine. Well, you're like, but I haven't seen this before right here, right? Yes, you have. I gave it to you. It's the very first one. It's sine squared plus cosine squared equals 1. We took that Pythagorean original identity and solved it for sine squared. So when we do that, sine squared of theta equals 1 minus cosine squared of theta. So we're going to substitute in the value that we had. Alright, so we're going to have sine squared theta is equal to 1 minus negative 3/5 squared. Well, negative 3/5 squared is going to give us a 9/25. Okay? And then we have a 1, so we have to do 1 minus 9/25. So 1 needs to be rewritten as 25 over 25 minus 9 over 25. So sine squared theta equals 16/25. Alright, and to get sine, we have to square root both sides. Square root of 16 is 4. Square root of 25 is 5. But we have to choose the negative value because we are in the third quadrant. Okay, so it's very important that we make sure we're keeping track of signs. Even though it may look like it works out positive, we're in the third quadrant. It needs to be negative 4/5. Same example here. This is working it how we did in the last lecture. Alright, we can plot the points, make a triangle, alright, and then use Pythagorean and do it that way. So sometimes it's easier to plug into trig functions, sometimes it's easier to just draw the triangle, plot the points, and then write all the ratios out for theta. So you can use whichever method you're comfortable with. I kind of challenge you to, hey, choose and try and alternate back and forth, or making sure that you're getting the same answer. So this is the easiest method right here, just plotting the points and writing the ratio out. Understanding and picking the correct trig function sometimes is harder for us to pick to substitute in for based on what we know. But give both of them a shot, okay, and then see which one you become more comfortable with. So, hey, just remember with all these videos, pause them to write stuff down if you need to. I would definitely make sure that you're taking notes. This is a lot of stuff to kind of think that you can just absorb and go knock out the homework right away. Okay. Also, if there's any issues on the homework, like funky symbols or things like that, something didn't copy through right, let me know so that I can make corrections for everybody. Sometimes some of these show up funky on someone else's screen versus yours or on your phone. So just let me know if there's anything that I need to correct on any of your homeworks. We should be doing homework 4 now and enjoying that. Alright? Please remember, email me or ask me if you have any questions. We're in person, ask me questions. Please always ask questions. I want to make sure that you understand everything. So if you're not remembering how to work with fractions or divide fractions and that aspect, or if you're still not comfortable with rationalizing a denominator, alright? Sometimes you haven't used those skills for a while and they kind of go away, but we got to make sure that we sit down and solidify them. Alright? This is it for Chapter 1. Alright, we'll be moving on to Chapter 2 next lecture.